Welcome to the PowTech Virtual Talks on Digitalization. This talk is from Aerzen. Lutz, Geerken and Ricardo Wehrbein will talk. Empower yourself and join the talk. Have fun and enjoy.
Yeah, Ms. Reutner, many thanks for this introduction. Also to all participants in this virtual room, good morning from the side of Mr. Lutz Geerken and myself. I would like to welcome you now to our presentation concerning the topic increasing of overall equipment efficiency through AI-based condition monitoring in the process air generation. We have taken this topic and we would like to introduce you in what is the scope of Aerzen and how we proceed to increase the overall equipment efficiency with the usage of artificial intelligence. I think most of you have heard about this because it's becoming a little bit like a hype over the last refocused on how it comes to the productivity and to the facility management as well. Let me give you a rough overview of the Aerzen Group. Aerzen was founded in 1864. We have 2,500 employees all over the world with a revenue of approximately 500,000 euros. And we are operating with worldwide 50 distribution and service companies on all 7 continents. These 15 companies are handling with our main components. These are the roots blowers, screw compressors, and turbo blowers as well. And we are operating in the oil-free market, so coming up to maximum 4 bar G. This is the main scope, and with this we are handling in the application fields of wastewater treatment plant for the aeration of the wastewater reactor, as well as the pneumatic conveying of goods, for example, cement or also flour in mills. So very rough range of several goods. And so all in all, we are the expert in conveying and compression of neutral and aggressive gases. And now today we are talking out of Hamelin. Hamelin is the base of our new daughter company, Aerzen Digital Systems. We was founded last year in October 2019, and we are a spin-off of our project called Aerzen 4.0. This project have the target to develop new digital service models, and for this we are looking to how we can extend the product portfolio of our basic products with these new digital services. The entity is led by Mr. Lutz Geerken and myself, and our core value for the group is that we have a very close collaboration between data analysts, statistics, and as well software and hardware engineers, and our utilizing specialist knowledge from the using equipment and with over 150 years of experience. And so we are matching the old world, the mechanical world, with the new world, the data and analytics part. And this is our core value, and we have in our vision that we take the customer in our center by taking any idea, and this is how we create benefits and values for the customer, and this is what we want to show you today and how we proceed with this. Let's come to the Gartner hype cycle. In my introduction, I've talked about artificial intelligence and how it become a hype, and here you now see 2 diagrams On the left side, it's the Gartner Hype Cycle of 2017, and on the right side, you see that one for 2019. And what you can see is that deep learning and machine learning is directly on the peak of the inflation of potential. So that means everyone was expecting that you can only place raw data to this artificial intelligence, especially to machine learning, and the result comes out of like magic. And now we're 2 years ago in 2019, and you can see that these points are going a little bit down on this line to the thought of disillusionation. So that means that not any expectation coming true, because now we have seen that we have to make in data preprocessing. And this is very hard work to make this preprocessing so that the artificial intelligence is able to find anything in these data. But this, my colleague Lutz Geerken will come on later on. As you can see, there are some years in front of us. So that means we are calculating, and as well Gartner is calculating, that it takes maybe 2 up to 5 years, depending on the brand in the application, to become a plateau of productivity. And now we would like to introduce you at first in the artificial intelligence, and also in how Aerzen is using artificial intelligence to increase the overall equipment efficiency. Let's talk about the artificial intelligence himself, because I think it's such a big word. It's becoming like a buzzword over the last years, as we have seen in the hype cycle of Gartner. And we have to differentiate between 2 kinds of artificial intelligence. The first one is the symbolic artificial intelligence, as you can see on the top. So that means it goes top down. So you have to pre-program rules where this artificial intelligence is following. So it means you have your network, you're putting into the rules and the data, and they're coming in result out of. I think this is very common, and this is a technique of the last years and decades, as you may know. What is now new is the neuronal artificial intelligence. So that means this is a technician coming from bottom to up. What is the reason behind? As you can see in the graphic, now we are not only placing the data into this neuronal network, we are placing the results into it. So, and we are creating by this the rules. So you're entering the data and the results, so you give a true or false, and by using this, we are getting the rules out of these neuronal networks. So it is self-learning with a continuous improvement, and you do not have to pre-program it. And this is the special thing about neuronal network. So you do not have to pre-program it, and this neuronal network will also find things which not have been pre-programmed, because it's self-learning and it's continuous improving. But this we will also come on later on and look how it works in the practice. We would like to introduce you as participants also in our products. So artificial intelligence is only a technology, but now we have to bring it to a customer benefit, and we call it Air Progress. Air Progress is more or less the roof of several products, because we are focused on the different demands of customers. On the bottom line, you see our basic product. It's called the Machine Park Management. Machine Park Management is a common fleet management, which is cloud-based in our Aerzen digital platform, where I will introduce you on the next slide. So that means there you have a rough overview of all your assets and devices directly inside of this platform. So this is the interaction platform between the machine and the human. In the machine part management, you can visualize all of your data, live data as well as historical data. You can see if you have any issues with the machines, like warning and alerts, which are coming from the machine control himself. If you now want to go step ahead, we have the possibility to make an energy management. So in the interpretation of overall equipment efficiency, we are now looking to how we can decrease the power consumption of our machines. Because if we are delivering the machines on site, they are on the peak of efficiency. But with the years and operating hours, the energy efficiency is decreasing. What is the matter? It could be that the environmental conditions are changing, that we have a clogging inside of our suction facility, and as well that we have any kind of interruptions are coming up from the process. So with our sensors and our measurements together with our artificial intelligence, we are looking to this higher power consumption and make a continuous improvement system. As you can see on the left side, it's called improvement system. So we can decrease the energy efficiency, or we can decrease the power consumption up to 20% by using this artificial intelligence over the complete life cycle of your machine. And then with the consumption certification, we take part of the reporting concerning the ISO 50001. So whenever you have your audit, you can use our reports directly from the machine to verify what you have done until the last period to increase your energy efficiency, to decrease the emission of CO2. And I think this is becoming much more need in the future. Now let's take a look to the right side, to the red one, to the condition monitoring. I think most of you have condition monitoring in mind when we are talking about the artificial intelligence. So for sure, Aerzen does have it as well. We differentiate between two use cases. In the ones we're looking to the maintenance scheduling, we call it usage-based maintenance. So our artificial intelligence is looking to the machine status and how reliable the machine is coming up from. We have a typically time-based maintenance schedule coming up from the operation plan, and the artificial intelligence is looking how good is the condition of the machine, and maybe we can extend also the period between maintenance so that you are reducing the time of downtime by maintenance up to 20 to 30%. But maybe some of our customers do not want to have a usage-based maintenance. They are running their complete production line in periods. So that means they are operating 340 days a year and have only a short window of 15 days to make the complete maintenance. They do not have any positive effects of this usage-based maintenance because they only have their window of 15 days where they have to schedule their complete maintenance. But they have an issue with unplanned downtime. So that means if they are running their period of 340 days, they do not want to have any interruption. And this we are taking care with our availability management. So here the artificial intelligence is also looking to the conditions of our machine, but now they are trying to scheduling if there is an unplanned downtime maybe. This could be that the machine is broken or there's any process matters are coming around to the machine which are decreasing the efficiency. And this artificial intelligence is then taking care about the customer so that it's planning the spare parts delivery, that is scheduling the service technician so that the unplanned downtime for the customer getting minimized. And now I would like to show you only in rough view into our Aerzen digital platform. As you can see here, this is our machine in one place. So you can see any kind of KPIs directly concerning to your machine as well to your complete facility. So if you have several machines, you can see your overall equipment efficiency for the whole facility. And but I think there I invite any individual of you to come back to me later on so that we can prepare maybe an individual virtual walk around to this platform. And now I would like to hand over to my colleague Lutz. He is now want to take you to one individual example to give you an idea how great is this product to increasing the overall efficiency.
Well, thank you very much, Ricardo, for this introduction and for the presentation so far. I would like to take the opportunity to give you one or two real-life examples. And I would like to say at the beginning that obviously the time is way too short to look into this very complex topic. So I invite everybody to contact us afterwards and get in touch and start a discussion with us. So I would like to start with a discussion on a real-life case of a package. You see on your slide an Aerzen package. And as Ricardo mentioned earlier on, it's very important to get the data and get the right data. So everything starts with the data. How do I collect the data? Where does the data come from? How do I pre-process the data? And only that leads to good modeling, and then at the end of the line of discussion leads to the right modeling and good results in OEE. So here you see an example of an Aerzen package. We take data from the control unit where we have some of the most basic data, input pressure, output pressure, so on and so forth. You see we look at power measurements, and you can also see the placement of vibration sensors. So very important for you as a user is that you work with somebody who has the experience to have the right placement of sensors, is looking for the right problems to solve here for you. Drilling in, the main part of any Aerzen package is the Aerzen stage. And also on the Aerzen stage, we have some sensors placed. Very important. I can only give you a very quick glance where these sensors are. Here we're looking at ball bearing vibration measurements and modeling, and you can see how to deep dive. So this gives you a rough overview where you have to place your sensors, where the data is coming from that we can see now, and that will lead to the data pre-processing. And I think you can't emphasize enough how important data pre-processing is for the whole analysis process. The example here is we're looking at data from an air filter, and I'd like to show to you that there is an optimal time to change an air filter, and I'm going to guide you through the numbers here. So first of all, we've seen where the data is coming from. The data is now coming into you via the sensors onto an analysis platform, and you have to keep in mind you have to normalize the data. So you have to look at the same conditions, the same external conditions, the same end pressures, and the same and you get results which are useful to you. You delete certain data points which are not relevant, maybe if the power intake is too low, and you work on missing data. And here you can see on the right in the tabling that you need a very clear overview of your data. You need to check for any inconsistencies, you need to check for any gaps in the data, and take all this into account. So once you've done this, you have the perfect starting point to go in. And here's a very visual overview as to what you can expect out of this analysis. On the left, you see a red bar. This would be the condition of the machine before an air filter change. and we want to save the end customer money. So we're looking at the power consumption and the power intake before and after. So the red box is just before an air filter change. Then we have the green piece of data histogram where we are showing the consumption right after, and we see, just to give you an idea, 3-4 months later, the decay again of the filter, and with that you have obviously a lower power consumption after you have a filter change. So the question you will rightly ask as a customer is, how relevant is this? Is this really relevant to me? How much money can I save by changing this filter? And statistically speaking, I'm a statistician. We have a team of mathematicians, statisticians, and software engineers, as Ricardo has mentioned earlier on as well, who actually look at all this data. How relevant is this statistically? Is there a real difference, or is this just a temporary fluke of the data? So we do various tests in the statistician speak. We are talking about variances, homogeneities, so on and so forth. This would be way too far now to go into these issues, but we're looking at, is this really relevant, what we're offering you here as a customer? And yes, I will quickly go over this slide. This is basically the main takeaway. Once you find an optimal point, you can save about 6% just using the optimal filter strategy change. And yes, it is important. Look for it. In this example, 4,000 operating hours, you can change a decent amount. So after changing, you still have spare change in your pocket. And this is just one example as to how we can increase overall efficiency here to you. I would like to go on and show you 2 more examples. One, I would like to visualize different areas of conditions or different conditions of a machine visually. Here you can see just a quick rough shot of various conditions in different colors, where we're looking at different sensors and groups, and obviously KI, neural networks, machine learning, deep learning are much more complex than this, but this is just a quick visual for you on this medium to show you that there are possibilities to visualize some of this as well. And I would like to wrap up this speech of mine just with coming back to the platform that Ricardo showed you earlier on, how we visualize the data from the sensors, and more importantly for you, summarize very briefly at the top with different visual items as to what the state of your machine is, where you can optimize, and we give you recommendations at the end. What can I learn from my data? How can I increase? We use the example of an air filter, but there are many more examples that can be used, and how you can actually gain value and increase your overall efficiency. So I would like to hand back to Ricardo for a final slide and wrap up. Thank you.
Yeah, thank you very much, Lutz, for this introduction into how we're using artificial intelligence to increase the OEE, and now a little bit different approach, not only looking to vibration sensors and so on, where we have so many products in the market, because we are now using our knowledge, and we are using this to also optimize the exchange of any wear parts. But now maybe some last words from my side, and coming up to a conclusion, and which potentials do you have to increase the overall equipment efficiency by using AI? I think we have to differentiate now 2 matters. At first one, it's a technology. So with our technology, we are utilizing several data. We are not only looking for vibration sensors or so on. We are using information sources and data coming up from the process, coming up from vibration sensors as well, and also environmental conditions, for example, of a weather RP. Because we have identified that several problems are not coming maybe up also only from the machine. It's coming up from influential factors like the weather, we have insuction, the suction conditions, we have moisture, especially for salmon plant. It's very important that we take care about the moisture, and these are also coming up from process values. And so all of these data are coming up to our platform and will be identified to any interruptions by the AI. And the next one is that we also identify unknown situation and events through our anomaly detection. Because in former times we only have our values for warning and alerts in case of vibration measurement, for example. But now we are building up correlations and dependings between individual values. And whenever you have an increasing of only one value, but the other values are not growing in the same direction, then we have this kind of anomaly, and this will be identified by our artificial intelligence. And now maybe some of you are asking, okay, why they are not coming earlier with this technology. And this is depending on our resources. And with this, I mean the Aerzen digital platform, which take place on a very performance running cloud infrastructure. Because with our Aerzen digital cloud, we do have the lowest runtime cost and only a very small amount for our customer of CapEx cost by using this scalable cloud infrastructure. If we would like to make the same calculations on an IPC, for example, the CapEx would be too large for the customer in regards to the benefit of the customer. And so now it's the right time to go this way with the new technology, with the new infrastructure, and to achieve these kinds of benefits. Yeah, which benefits I'm talking about? I talk about the benefits of identification of efficiency problems in the machines and to presenting the customer suggestions to minimize the total cost of ownership. And as we have seen, only with this small part, these filter clogging, we can decrease the total cost of ownership over 6%. And this is only the beginning. We do not have talked until now about all the other influencing factors as well as the downtimes. Identification of unplanned downtimes is also very important, as I have said in the condition monitoring, as well as the extending of the mean times between failure and mean times between maintenance, and also the mean time to repair. As I have mentioned with the availability management, we can see an unplanned downtime before it comes around, so that we can schedule spare parts as well as service technicians to your side to make this time to repair very, very low. So, and now I would like to say thank you for your participating. We hope that you have maybe get a feeling of how important artificial intelligence is becoming in the future to increase the overall efficiency. Now for this example in the air treatment, but I think also in several other industries. And if you have further questions or also would like to take an individual workaround to our Aerzen digital platform, do not hesitate to contact us. You can use on the left side also the phone to get in contact us, or if you're only interested to follow us, please visit our website or as well as our LinkedIn channel. there we are preparing individual information from time to time so that you're keeping informed. And now I would like to hand over back again to Ms. Reutner to now coming to the individual questions you might have. So thank you very much. Stay healthy and enjoy your day.
Thank you very much. Very interesting lecture. Thanks a lot for this, Ricardo, Wehrbein, and Lutz Geerken. They were from Aerzen Digital Systems. That was so concrete and at the same time so inspiring that I think many of our users can now imagine why AI can be useful in process air generation. I am now opening the question answer session and would like to put a question in front that may be of general interest, I think. Why did you establish a separate company as Digital Systems? Is the subject condition monitoring and energy management not a part of your core business?
I think we have taken this advantage to maybe go offsite. As I have written in the chat before, we are not placed at Aerzen directly, we are placed in Hamelin. We have two reasons for this. The one reason was that we have looked for other employees than the Aerzen Maschinenfabrik himself. As Lutz also mentioned, we are looking for data scientists, data analytics, soft and hardware engineers. So for this looking around, it was very important that we have also a good connection to traffic for railways and so on, to get the right people also here to the wonderful Weserbergland. And the other reason was that we try to build up a new spirit in our company. I think all of you know how is the spirit in a company like the Aerzen Maschinenfabrik. It's heavy, it's duty, and we have a little bit other approach. And this was the reason why we have taken this opportunity to go to Hamelin and focused only on this artificial intelligence matters and also the platform.
Okay, thank you. Now there are many questions in the chat, and I think I switch over to my colleague Miriam. Thank you.
Hello, so back again. There are three questions. Tobias Köckel is asking, just 1 second, I try. If you would like, you can also go into the active part and ask your question. Taylor.
Yeah, I think that depends on the actual failure that you have. There's concrete examples where you can see failures various hours before. It depends on the type of failure, is the quick answer. But you can see, especially in vibration management, a failure time leading up, which is much longer than that. So that will be the quick answer. The first is it depends on the type of failure you have. And secondly, it varies from a long pre-run period to a couple of hours before the machine. That would be our examples. And as I said, we only have a few minutes here to delve into this. I would refer the participants to get in touch with us to discuss this afterwards. I would be available for that. I've seen one other question in the chat, which is asking what type of tools do we use? Basically, I think you have to rephrase the question somewhat. Basically, everything is in Python programming, and obviously there's various IDEs, programming platforms that we use. We use quite a few of them. So if you're interested, I would have to refer you to the colleagues as well to look into this. But as I said, the whole topic of machine learning is very wide and very fractured. We work together with universities. We have our experts on our team, and we use many tools from IDEs, but mainly the modeling is done in the programming language Python. We would do some pre-speccing in a statistical language called R, especially if we want to get any idea as to what we are looking for in data pre-processing. But this will be my quick answer to that. I would also like to refer you to get in touch with us afterwards to get into more detail.
Yeah. Thank you, Lutz. I've seen also one further question coming up from Jos Carbajo. He's asking for an example to monitor an existing compressor. What is the percentage of investment dedicated to the hardware and software, respectively, to the typical project? I think for an existing compressor, a typically compressor, not a Lutz blower, and screw compressor is costing around about 15 up to 100,000 euro, and we are handling our products in hardware is costing about 1 up to 2%, so it's very small amount of capex, as I mentioned, and the runtime costs are coming across of around 100 up to 200 euros per month. And this is depending on which package do you want. Do you only want to have the machine monitoring, or do you want to extend it also to the condition monitoring and energy management? So all in all, I would like to say that you have around 1 up to 2% capex and around of 1% operation cost per year to the overall invest of the compressor.
Okay, so I think there are all questions clear. There is one more. Tobias Köckel is asking again, is this filter change interval not simply a functional of the filter price versus the electricity costs?
This is a good question, and as we have mentioned, it's depending also on environmental conditions. So you could imagine that you do not have to make this on an individual value of pressure loss and electricity cost, because it's depending so often. And typical Lutz blower is much more affected on this pressure losses on suction side than in screw compressor by the ratio of differential pressure, as well as Mr. Köckel was asking for electricity costs. And we are handling also individual electricity costs. We are calculating with a standard value, but the customer can also enter individual electricity costs. And this is not so easy to pre-programming into a simple control system. And this is the reason why we have taken this into our platform. And as you may have, or as you may know, you have also environmental conditions. For example, if you have a big field near to your facility, and I think now in the autumn, when the farmers are going to the fields, the impact on the filter is much higher than, for example, in the winter season and so on. So, and this was the reason why we have taken this to our platform and not the individual control system.
Thank you. So thank you very much for all answering those questions and for this great presentation. If you would like to contact Aerzen Digital, you see the contact here, and you can of course also write to us afterwards. This is also recorded, so you can also ask for the recording. That's also no problem. And Mr. Wehrbein and Herr Geerken, thank you very much. Enjoy your day. Thank you for your inspiring speech, and hope to see you soon.
Yeah, thank you very much. Okay, stay healthy. Bye.
Bye-bye. Thank you.
Also by my side, many thanks to Lutz Geerken and Ricardo Wehrbein from Aerzen. Can you hear me all right? I hope so. Miriam? Yes, thank you. I may now lead over to our second speaker and our second topic, disruption. Better we do it than others do. That's the topic. This is certainly a consideration that many industrial companies are making today. The digital transformation inevitably means change, and extreme change at that. It is not for nothing that the keyword disruption is often heard in connection with digital change. There is talk of new business models that digitalization opens up. Do we want